Hello friends, so here we go with the problem number 41. An hexagonal lamina 25 mm side rests on one of its corner on HP. The lamina makes a 45-degree to HP and the diagonal passing through the corner on which it rests makes an angle of 30-degree with the VP. Okay, so draw its projection. So normally here we have one hexagon, okay, which is of 25 mm on HP with one of its corner. So that is the first one, okay, what we require for the first position. Next one, the lamina makes an angle of 45 degree. So here it's an HP, so it is inclined to the HP itself. That is a diagonal. So diagonal is inclined. So next it is inclined at 30 degree to the VP. So here the important thing to be noted is the diagonal is inclined. So whenever we say a diagonal is inclined, it's a locus line problem. Okay, so we'll see at the end of this video. Okay, if they say the diagonal appears to be inclined, okay, if it is appears to be inclined, so it will be no locus line, and how we can do that one. So we'll complete both the things in a one video. Okay, so it is resting on the corner, so just take a one reference line. Okay, so write a VP HP. Okay, so now, so the side is 25 mm. Take a radius 25 mm. Take any one reference point. Through that one, just drop on a thin circle. So resting on the corner, so have the horizontal diameter, and through this one you just cut the 25 mm arc both the side. Like this. Okay, so now you will get an hexagon resting on the corner. Okay, just dimension that one. So this is 25. So we'll write from A, B, C, D, E and F. Okay, so once this one is done, take the projections. Okay, so we are viewing from here, so we'll write this is A dash, this is F dash, B dash, so E dash, C dash, this is the D dash. Okay, so now this is the a diagonal. Okay, you just mark this measurement, measure it. Okay, so it is coming around 52 for me. You just write. Okay, and now the diagonal is inclined at 45 degree to the HP. So now take any one reference point. Oh, take a 45 degree. Okay, so directly you can take the 52. It is around 52, or else you can take a line at a 45 degree and then cut the arcs also. So now from here just take the reference from both the ends, 1 here and 1 here. Have those arcs thin, so it is just to identify the things. So this is A dash, So F dash B dash, so E dash C dash, and this is a D dash. So now to have the projections, first rightmost and the bottommost. So I have all the horizontal because only 3. Okay, so now this is A till A, so this is F and B, and this is E and C. So this is A, B, C, D, E and F. Okay, so once this one is done, just drop this diagonal and measure. So it is coming around 37. Okay, so now once this much is done, so now the third position, diagonal is inclined at a 30 degree. So take any one point and to take a 30 degree, just drop a line. Okay, and while taking this reference, that is the first diagonal, take the first diagonal reference, take well below the XY line, just cut an arc. Okay, so this is A, so this is the arc. Then we'll go with the horizontal line, then we'll take the second diagonal line, and from the same reference point we'll draw, and this is our D. Okay, so when this one is done, we drop a line passing through the A. So this is the initial 30 degree. So now you measure this angle, you are getting around 45. You write this is 45. Okay, so now we got AD, so this AD. So now through this one you measure how much is this distance. Okay, so it is around 45, so 22 and half, 22 and half. Just keep a scale here, okay, perpendicular to that one. Drop it, 45. Okay, so this is where we are going to get even through the A also, you just drop 45. Okay, so once this one is done, we can just connect these two ends with a thin line. Alright, so next from this corner, okay, take a F. You just see where is he, so it will remain same. Okay, so this is our A, so we are tilted like this, so B, C, D, so this is E and this is the F. So we just connect. Like this. Okay, so this is how exactly we can construct. Just like we have 3 lines. Okay, so we got a AD. From there you measure this distance and this distance. Okay, from A to B, like on this line, and just drop a 2 lines. Okay, just have a thin line from corner you take the reference, just mark it, you will get this one. Okay, so when this one is done, now to take the reference, have the topmost and rightmost. So this is a C, so this is a D, and this is a B, so this is a till to the XY line, so we can directly write this. So this is a F and this is a E. Okay, so now this is D, so D dash. So on this one it's E and C. Okay, so you can see this is a E and this is a C. So this is C dash and this is a E dash. Okay, so on this one F and B. So this is F dash and this is a B dash. So now take A to F, F to E, then D, C, then B, then to the A. Okay, so this is exactly you will get the pentagon. Okay, so now this is when they say the diagonal is inclined. Okay, suppose there is a diagonal appears to be. Okay, diagonal appears to be, or they say the top view of the diagonal is inclined. Okay, remember these two, appears to be and top view. So then you need not to take a locus line. So whatever the angle they are going to give, just take that angle, take the second diagonal directly, and you construct the hexagon. Say for example, the question number is 42. Okay, just will read that question. Okay, so hexagonal lamina 25 mm rests on one of its corner. The lamina makes 45 degrees. Same. The diagonal passing through the corner on which it rests appears to be inclined. See here, appears to be. Okay, here it is inclined directly. Here it is a appears to be. So at that time you need not to take the first diagonal length as a reference. Okay, so what we can do, we will take a directly, say, one reference point and a 30-degree line. Say for example here, so we'll take a 30-degree line. Okay, so now we'll take the second diagonal directly, this one, and we'll cut it on the 30-degree line. So we'll directly say this is A and E, and we'll construct the hexagon. Okay, so that's an important thing in that one, right? So, and if you can see in that one, so sometimes they will give it is a top view of the axis, means top view of the axis is inclined. Say for example, we have one circular lamina problem, so where we will get that top view of the axis. I will show that one. Say now here, so we have number 46. Okay, so in that one, draw the projection of the circular plane, negligible thickness 50 mm, resting on HP. The lamina is inclined at 45 degree to the HP, means resting on HP, inclined to the HP. And here see the top view of the diameter. So top view of the diameter means it is appears to be. Okay, just one thing is, see, whenever in a projection of planes we have median for a triangle, okay, and bisector for a pentagon, and diagonal for a square as well as a hexagon, and diameter for a circle. Okay, so if these are specified, as inclined to VP, okay, or HP, then it is a locus line problem. Okay, all these things will come in a third position. All these things will come in a third position. If they say these things appears to be inclined, or the top view of the anything, this, okay, any, say like a top view of the diameter is inclined, means it's a no locus line. Okay, so if it is inclined to the VP, so then we call that one as a beta line problem. If it is inclined to the HP, then we call that one as a alpha line problem. Okay, so this is very important. So these things are very important to be noted. You can just note a point that one, and clearly you can solve all the problems in that one, right? Thank you.